The following is an ESG Lab video.
Welcome to another ESG Lab video summary, where I'll be reviewing the results from our recent testing of MapR Streams with a key focus on performance, scalability, and reliability. Now that the Internet of Things is more than a buzzword, organizations are starting to rethink their existing BI analytics strategy. ESG research shows that 45% of organizations planning to deploy a new BI analytics solution are doing so over the next 24 months. Of those organizations, 26% are doing so because their current solution is not meeting their requirements. So what's the top requirement for driving the evaluation process? The move to a more real-time analytics approach. As organizations look to gain real-time insight from these massively growing data sets, they run into additional complexities. Geographic distribution of organizations and devices has forced organizations to either analyze a subset of data from a specific location or delay data analysis until the data has been merged into a central location. To avoid incomplete analysis or short-sighted insights, many organizations are forced to wait for all the data before making business decisions, imposing data pipeline processing delays that not only hurt the current state of business, but also potentially impact what could be a timely competitive business advantage. The MapR Converged Data Platform is a collection of open-source engines, tools, and applications that leverage purpose-built MapR platform data to deliver a scalable, reliable, and secure infrastructure for global data-driven applications. 3 core services work together to enable MapR to truly be a converged platform: MapR FS, MapR DB, and the newly released MapR Streams. MapR Streams is a published subscribe system that takes data from producers and gives it to consumers. The producers and consumers are decoupled across topics, which are managed and stored in a MapR cluster. Using weather as an example, the producers would be various sensors spread across the globe, the topics would be information like temperature, wind, and pressure, and the consumers would be the applications used to process, analyze, and share the data. In many cases, topics work hand in hand and therefore can be managed together. This is called a stream, which can be asynchronously replicated between globally dispersed MapR clusters with publishers and consumers existing anywhere. Our primary goal was to validate the performance capabilities of MapR Streams, and with no open source industry standard tools available to test performance, MapR created a multi-threaded shell application called Rubix to simulate event streaming workloads. We analyzed 4 test scenarios that represented common situations in real-time environments. The producer test measures the message ingest rate. The consumer test measures how quickly the messages can be consumed or read. The Tango test combines the two to measure overall system performance from production to consumption. And the Slacker test is a slight variant of Tango in that the producer test is started first, and then after a set period of time, the consumer begins, which measures the performance of the consumer catching up to the producer. We analyzed messages per second and throughput for each test case with replication factors of 1 and 3. Across the board, we witnessed each test scenario support millions of messages per second. ESG Lab was particularly impressed with the ability of a 5-node MapR cluster to handle the ingestion of nearly 7 million messages per second. Further, when consuming those messages after they were generated, over 18 million messages were consumed in the correct order without any data loss at rates as high as 3.5 gigabytes per second. Next, we turn to reliability. MapR Streams inherits the existing reliability benefits of the overall MapR Converged Data Platform, delivering an always-on, highly available infrastructure to handle the continuous flow of real-time data. Testing was done using the Jepsen test suite, which tests the consistency and availability of distributed databases by simulating network partitions. After MapR Streams passed all the pre-packaged Kafka ISR test failure simulations, custom failures were configured that were specific to MapR functionality. 8 total tests were categorized into 3 test groups. Node partitioning tests removed master nodes from the cluster, node services tests simulated the termination of all services on master nodes, and cluster services tests terminated specific MapR services on random nodes. Across all the MapR failure scenarios, we witnessed instant failovers, automatic service restarts, and real-time recoveries, while the flow of data remained uninterrupted with no data loss. So why does all this matter? MapR delivers a big data storage and processing infrastructure that manages data from initial generation and ingestion to consumption and real-time insight through industry-proven MapR services, open-source engines, and commercial applications. We validated that MapR Streams met the demanding performance requirements of processing streams of big data in a real-time analytics environment. Scalable event processing performance was achieved across a 5-node MapR cluster that ingested and consumed millions of messages at high throughput levels. By inheriting the existing benefits of the overall MapR infrastructure related to high availability and reliability, MapR Streams handled a consistent flow of data across a single platform, eliminating the need for multiple tools and processes that add additional complexity. When simulating various failures across the platform, the no single point of failure architecture maintained uptime to handle the constant flow of real-time data. Services failed over, restarted, and no measurable impact was measured on the data flow, which continued throughout the failures with no loss of data. For MapR, a publish-subscribe event streaming service was required to create a truly comprehensive platform of fully integrated data services. MapR Streams provides that global event stream processing system that turns MapR into a highly performing, ultra-reliable, enterprise-grade converged data platform to meet the demands of batch and real-time processing on a global scale. If you'd like to learn more, read the full report on ESG's website.